Today I will explain some important sums from the chapter Definite Integration of class 12. Sum number 1. 0 to pi by 2 sine 2x by sine 4x cos 4x dx. 0 to pi by 2 sine 2x, I can write sine square x whole square x plus 1 minus sine square x whole square x dx. Then put sine square x is equal to t. So differentiating both sides, 2 sine x cos x dx is equal to dt. That means sine 2x dx is equal to dt. When x is equal to 0, t is equal to 0, x is equal to pi by 2, t is equal to 1. You can frame a table 0, 0, 0, 1. It will help you. Now, I is equal to 0 to 1 dt by t square plus 1 minus t whole square is equal to 0 to 1. If I split into formula, we will get dt by 2t square minus 2t plus 1. I will take that 2 as a common factor from the denominator. So 1 by 2, this is 0 to 1 dt by t square minus t plus 1 by 2. Now 1 by 2, 0 to 1 dt by t square minus 2 into t into 1 by 2 plus 1 by 2 whole square plus 1 by 2. It was not there, we insert, so we will subtract that value. So that one we converted into a formula. So dt by, I will write t minus 1 by 2 whole square, and if I simplify, we will get 1 by 2 whole square. Here I will use the formula dt by t square plus a square, 1 by a tan inverse t by a. That formula I will use here. So what will I write? I will write 1 by 2, 1 by 2 tan inverse t minus 1 by 2 by 1 by 2 whole 0 to 1. If I put the values, so we will get tan inverse 2t minus 1, then this is 0 to 1. Now we will put upper limit and lower limit. So we will get tan inverse 1 minus tan inverse minus 1. So we will get, this is pi by 4, this is minus, so it will create, that is plus. So this is pi by 4, that is equal to pi by 2. Therefore, I is equal to pi by 2. This is the answer of the first sum. Now, important sum of this chapter is 0 to pi by 2 root tan x plus root cot x dx. Here put tan x is equal to t square. Differentiating both sides, so sec square x dx is equal to 2t dt. I will split that one. 1 plus tan square x dx is equal to 2t dt. So dx is equal to 2t dt by 1 plus t to the power 4, because tan x we consider t square. Okay. Now when x is equal to 0, t will be equal to 0. When x will be equal to pi by 2, t will be infinity. If you want, you can write in a tabular form 0, 0, pi by 2 and infinity. So sum will changes to 0 to infinity, t plus 1 by t into 2t by t to the power 4 plus 1 dt. Okay. After that, I will take the LCM and simplify. This denominator t and that one will be cancelled after simplification. So what will you get? You will get 2 0 to infinity t square plus 1 by t to the power 4 plus 1 dt. So divide numerator and denominator by t square. So 0 to infinity 1 plus 1 by t square, then t square plus 1 by t square dt. Then I will keep numerator intact and denominator is t minus 1 by t whole square plus 2. As in numerator plus, so we take denominator as minus. This is dt. So again put t minus 1 by t is equal to u. If I differentiate, 1 plus 1 by t square dt is equal to du. Look this. This is minus. When I differentiate, this will be plus. As in the numerator plus, so we consider this is minus. After converting this one, you have to change the limit. When t is equal to 0, u will be equal to minus infinity. T is equal to infinity, u will be equal to infinity. In a tabular form, t and u 0, minus infinity, infinity, infinity. So I will be converted to minus infinity to plus infinity. Okay. And then this is du by u square plus root 2 whole square. Here we will use the formula minus a to a fx dx is equal to 2 of 0 to a fx dx, as fx is even function. Okay. So I will change that. This I will convert it to 2 into 2, 0 to infinity du by u square plus root 2 whole square. Here I will use the formula dx by x square plus a square. This formula 1 by a tan inverse x by a. That formula we are going to use here. So this is 4 1 by root 2 tan inverse u by root 2 and then whole 0 to infinity. So this is 2 root 2, then put the values tan inverse infinity minus tan inverse 0. So if I simplify, I will get 2 root 2, then pi by 2 minus 0. This is equal to pi root 2. This is the answer of the second sum. Now I will take sum number 3. This sum is minus 5 to 0 mod x plus 2 mod x plus 5 dx. This sum is very important for board exam. Here I will use the formula a to c fx dx. I will insert b, a to b fx dx plus b to c fx dx. I insert here and there, a to b, so this e and c will remain intact. Okay, this formula I will use for this sum. Wait for a moment, I'll show step by step. Here I will insert minus 5 to minus 2. I will write mod x plus 2 plus mod x plus 5 dx plus minus 2 to 0 mod x plus 2 plus mod x plus 5 dx. Look, I insert minus 2 here. So minus 5 to minus 2, within that range, modulus x will be negative, modulus x minus 2 will also be negative. And minus 2 to 0, only modulus x will be negative, other two will be positive. So I will write down the first part, minus 5 to minus 2, this will be minus x, minus of x plus 2, and this is x plus 5, then dx. And the second part, minus 2 to 0, first part will be minus x, second part will remain intact, x plus 5 also remain intact. If I simplify, I will get minus 5 to minus 2, minus x plus 3 dx plus minus 2 to 0, x plus 7 dx. Now we will simple integrate. So we will get x square by 2 plus 3x, this is minus 5 to minus 2, plus this is x square by 2 plus 7x minus 2 to 0. Now we will put the values. After putting the values, we will get minus 8 plus 55 by 2 plus 12, this is 63 by 2. This is the answer of the third sum. Now we will shift selected sum number 4. Minus pi by 2 to pi by 2 fx dx, where fx is equal to sin mod x plus cos mod x. You have to solve this sum. Look, first I will write I is equal to minus pi by 2 to pi by 2 fx dx is equal to minus pi by 2 to pi by 2 sin mod x cos mod x dx. Here fx is even function. Therefore, we can use the formula minus a to a fx dx is equal to 2 0 to a fx dx. So from there, what can I write? I can directly write 2 of 0 to pi by 2 sin x plus cos x dx. So simple integration 2 minus cos x plus sin x 0 to pi by 2. After putting this value, we will get 1 plus 1, this is 4. So 4 is the answer of sum number 4. Another important sum of this chapter is 0 to 1 cot inverse 1 minus x plus x square dx. We know cot inverse x is equal to tan inverse 1 by x. We will use this formula here. 0 to 1 tan inverse 1 by 1 minus x plus x square dx. I will little bit adjust this sum. Tan inverse x dx, here 1, from there minus x common, 1 minus x. I will write in the numerator x plus 1 minus x. Look, this step and that step remain intact. So this one I will use the formula tan inverse a plus b 1 minus ab is equal to tan inverse a minus tan inverse b. This formula I will use for this sum. So I will write 0 to 1 tan inverse x dx plus 0 to 1 tan inverse 1 minus x dx. Okay. For the first part, it will remain intact, tan inverse x dx. For the second part, I will use 0 to 1 fx dx is equal to 0 to 1 f of 1 minus x dx. So I will write 0 to 1 tan inverse 1 minus, in place of x, 1 minus x dx. Okay. So what will I get? I will go for next slide. I will get I is equal to 0 to 1 tan inverse x plus 0 to 1 tan inverse x. That means 2 0 to 1 tan inverse x dx, both dx. Okay. So I will consider 2 tan inverse x into 1 dx. This is the first function, this is the second function. So 2 will remain intact. So I will write tan inverse x integration dx 0 to 1 and 0 to 1 d dx of tan inverse x dx, then dx, this is 0 to 1. Okay. Now I will move for next step. So this will be 2 tan inverse x into x, this is 0 to 1. Then second part 0 to 1 1 by 1 plus x square into x dx. So this is 2 tan inverse x x 0 to 1, 1 by 2, 2x 1 plus x square dx 0 to 1. So I can write 2 tan inverse x into x minus 1 by 2, 2x here, 1 plus x square. So directly we can write log of 1 plus x square. Okay, 0 to 1. Now we will put the values. So what will I get? This is 2, then tan inverse 1 into 1 minus 1 by 2 log 1 plus 1, then this is minus 0 minus 1 by 2 log 1, that will be 0. If I simplify 2, this is pi by 4 minus 1 by 2 log 2, then the final step pi by 2 minus log 2. This is the answer of this sum.